NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will learn a clean and reliable method to solve first-degree rational inequalities, and then apply it to a worked example. Here is our required display. The word example appears, followed by the general problem statement in bold orange. Step 1. Move all algebraic expressions to one side, so the inequality has 0 on the other side. We target a single rational expression. Step 2. Use a common denominator and factor the numerator and denominator. This produces a single simplified fraction. Step 3. Identify critical points from zeros of the numerator and the denominator. These points split the number line into intervals where the sign is constant. Step 4. Make a sign chart. On each interval, choose a test point and determine the sign of the fraction. Then select intervals that satisfy the inequality symbol. Step 5. Remember the domain restriction. Values that make the denominator 0 are never included. Now, let's apply the method to a concrete inequality. Example. We will solve the inequality. The fraction 2x minus 1 over x is greater than 1. Step 1. Subtract 1 from both sides to move everything to the left. Apply inequality manipulation. The result is the fraction 2x minus 1 over x minus 1 is greater than 0. Step 2. Combine into a single fraction. Replace 1 by x over x and combine numerators. We get 2x minus 1 minus x over x is greater than 0. Simplify the numerator to x minus 1 over x is greater than 0. Step 3. Determine the critical points from the numerator and the denominator. The numerator x minus 1 equals 0 gives x equals 1, and the denominator x equals 0 is undefined. These are our critical points, 0 and 1. Step 4. Analyze signs across the intervals determined by the critical points. We study the sign of x minus 1 and the sign of x, then the sign of the fraction. The positive intervals are minus infinity to 0 and 1 to infinity. Step 5. Write the solution set. The inequality holds on open intervals, so the answer is the union of negative infinity to 0 with 1 to infinity. In this lesson, we solve a parameter inequality step by step and then interpret the result by cases on the parameter A. First, here is the example and the problem statement in bold orange math. Step 1. Subtract 1 from both sides. Then put everything over a common denominator and simplify the numerator carefully. Step 2. Find the critical x values where the expression changes sign. These are the zeros of the numerator and the denominator. Then factor to expose a constant sign factor. Step 3. The constant factor, open quote, 1 minus a close quote over a, controls whether the sign pattern is preserved or flipped. We will split into cases, a between 0 and 1, a less than 0 or greater than 1, and the special cases a equals 0 and a equals 1. Case A. When 0 is less than a and a is less than 1, the constant factor is positive. Therefore, the rational expression is negative strictly between the two critical points R1 and R2. For this range of A, R1 lies to the left of R2, so the solution is R1 less than x less than R2. Case B. If it is less than 0 or it is greater than 1, then the constant factor is negative. That flips the sign pattern. So the rational expression is negative outside the two critical points. For these values, R2 sits to the left and R1 to the right, and the solution is x less than 2 over a, or x greater than open parenthesis 3, a plus 2 close parenthesis over a minus 1. Case C. When it equals 0, substitute directly. The left-hand side becomes x plus 2 divided by negative 2 less than 0, which is equivalent to x plus 2 greater than 0. Therefore, x is greater than negative 2. Case D. When it equals 1, the expression becomes 5 over x minus 2 less than 0. That is negative exactly when x is less than 2. To wrap up, here is a clean summary of all solution sets by cases on the parameter A. Great work! We turned the inequality into a single fraction, found critical points, and used sign analysis to solve it across all parameter cases. Here is the problem statement, red in orange. Quick challenge. Before we start, can you predict the first algebraic move? Step 1. Start with the given inequality, unchanged. Step 2. Subtract 4 from both sides to move everything to one side. Step 3. Combine into a single fraction and simplify the numerator. Then, simplify the coefficients to a clean factored form. Step 4. Find the critical points by setting the numerator and denominator equal to 0. Step 5. Compare the two critical values to understand their order. We compute their difference exactly. Because the sign of a minus 10 determines the order of these points, we split our work into 3 cases: less than 10, greater than 10, and equal to 10. Case 1, a less than 10. Then the difference is negative. So 4/5 is less than the other critical value. We solve the rational inequality accordingly. Case 2, a greater than 10. Now the difference is positive, reversing the order. Solve the inequality to get the open interval between the 2 points. Case 3, equals 10. Substitute into the inequality and simplify. Since 163 and 5 are positive, the denominator controls the sign. Great work! Quick check. Does each interval exclude the point where the denominator is 0? Here is the complete answer, color-coded in green. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.